So before break, guys, again, we talked all about the concepts and the theories of the different types of acids and bases. We talked about conjugate pairs. We're now moving away from that. We're going to start applying all of those ideas and concepts to the mathematical equations and expressions. All right? Just as a little review right here, this shouldn't be any big shock to us, guys. Pure water is neutral. Why is it neutral? Well, because the hydrogen ion concentration equals the hydroxide ion concentration. And this is something that we wrote down in our notes from before break, but we're going to jot it down here again. So H plus ion concentration equals the OH minus concentration. And again, that equals neutral because they're balanced out. Those ions are balancing each other out. All right, and that's the key idea as to what makes something neutral. Right? You get the same amount of ions of each. Now, just as an aside, this new packet, folks, is an extension of the old one. Okay, I have those. I'm going to try and pass those back to you today while you're doing some practice. You're going to staple this packet to the other packet or want to keep them together in some way because you're going to be studying all of the information for your test, which, by the way, your test is next Thursday. So, if the hydrogen ion concentration is more than the hydroxide ion concentration, guys, what type of solution do we have? Yeah, it's an acidic solution or acidic substance. And then if the hydroxide ion is more, what do we have? Basic. Exactly. And again, this is a review. This should be no shock to us, all right, at this point in the year, since we've already covered all the basics with acids and bases. So now, guys, we're going to start talking about the equations. Get your reference packets out if you don't already have them out. You all need to see where this is. All right? Don't be asking me any questions on your test or quiz because I can't answer those. You've got to know where they all are, and you've got to be able to do the practice. Guys, I'm telling you, you've got to get used to using these calculators because these are the ones you're using on your quiz on Friday and your test on Thursday or next Thursday, just like you've been using them all year long. You've got to know where the buttons are and how to plug them in to get the correct answer. Yesterday, some people were already saying when we watched the video that, hey, I'm not getting the right answer. It's because you're not putting them into the calculator correctly, most likely. All right, so here is our first equation. If you look on your reference pack, all right, this equation, guys, is the fourth equation from the bottom. This is called Kw. Kw is the ionization constant of water. All right? Water is something, guys, that will self-ionize slightly. It doesn't do it all the time. It doesn't do it a lot necessarily or really strong, but it will self-ionize, making the hydrogen ion or really the hydronium ion, and it will make the hydroxide ion. Okay? Because remember, back before break, water is unique because it can act as either an acid or a base. Prize question, what is that called? All right, amphoteric, guys, and water's that. So that's what we're looking at here, is that it's the concentration. So one thing to jot down off to the side, all right, right here. Whenever you see brackets, folks, that means concentration. And what do you think our unit is for concentration? C. Nope. Oh my goodness, we're still on spring break mode. Yeah. Right. Concentration, guys, we did this before break. We did this in our solutions unit. Molarity, there it is. Molarity, capital M. All right, capital M. So, we have to figure out the concentration of our two ions. All right, so here we go. Example number 1. It says calculate the hydrogen ion concentration and the hydroxide ion concentration for a solution of, what's HNO3? Nitric acid. All right, for a solution of nitric acid with a concentration of 1 times 10 to the minus 4 molar. First step, guys, with every problem. Okay, before we get into that, a little aside. There are 6 different equations that we're going to be using over the next 2 days. We're going to learn about them between today and tomorrow. Okay, they will be the ones that are on your quiz on Friday. You will find that there are 2 different ways that you can solve almost every problem. Okay, within this unit. I will have a roadmap for you guys tomorrow that will kind of show you, be lined out, hey, this could be one way I could go, this could be the other way. You're going to find and need to find the way that you are most comfortable with and then do it that way every time. One way might be 3 steps where the other way is 1, or vice versa, depending on the problem. You'll see what I mean as we get through all the equations. Okay? The first step, though, no matter what problem you're solving, what do you think the first step is? Any ideas? It's the most important thing. What's that? That's going to be the second thing. So what Briley said is figure out the ratio of hydrogen. Okay? Kind of, I think it's the second step of what she's getting at. But there's even a more basic step than that, huh? Pun intended. Think about that.
Tell if it's either acid or
Yeah, tell if it's either an acid or a base, guys. That's your first step. You have to identify if it's an acid or a base. So in this example number 1, what do we have? How do we know it's an acid? It has the H in it, guys. So because of the H that we have right here, we have an acid. All right? Which ion do acids produce? Not a trick question. The hydronium or the H+, right? Hydronium, guys, and hydrogen are the same thing. I'm going to jot this one down as well. H+ equals H3O+. They mean the same thing. So, this formula, guys, this substance here is going to give us the concentration of the hydrogen ion. Okay, because it's an acid, it produces those hydrogen ions. So this concentration right here is going to help us get the hydrogen ion. That's our step 1. Whatever substance we have, whether it's an acid or a base, that's going to guide us to the first of our 2 concentrations. Because if we look at this formula that we're going to use right here, we can't have 2 unknowns, right? We cannot have 2 unknowns, so we've got to have one of those be known, and that's based on whatever substance you're starting with. All right. What is our concentration of hydrogen ion going to be here, do you think? This is, I think, what Briley was talking about, looking at that ratio of hydrogen. How many hydrogen ions do we have in this formula? 1. So, guys, if we have 1, whatever your concentration here is what it's going to be. Remember the video yesterday, those of you who were here. Okay? If you saw OH2, you had to do what to that number? To that concentration, that molarity. You had to multiply by the 2 ions. Folks, we only have 1 ion here. If we look at our formula, for HNO3, we have a 1 right there. So we're going to multiply that by 1, which is just the same thing. So hydrogen ion concentration equals 1 times 10 to the minus 4 molar. One of them is done. Now we've got to use our formula to figure out the other one. So, for example, before we get into that, if I said A times B equals 1 times 10 to the minus 14, if I said solve for B, how do I solve for B? Divide by A, right? Because they would cancel out. And then it would be B equals 1 times 10 to the minus 14 over A, correct? You all can do that. We've done stuff harder than this year. Nope, don't do that. All right? Now, you guys just showed me that you can solve this equation no problem. OH minus concentration times hydrogen ion concentration equals that. So though the variables look different because there's brackets and there's charges, okay? Though they look different, guys, the math is exactly the same. Which of those 2 ions do I already know? H+. So I need to get OH, the one I'm looking for, by itself. How do I do that? Divide by H+, right? Don't get hung up, guys, in the brackets and in the charges. It's just like saying A times B equals 1 times 10 to the minus 14, and then solve for your unknown variable. But they look a little bit different. So we're going to divide both sides by H+, concentration. Down here, then we can plug it in. OH minus equals 1 times 10 to the minus 14 all over, what's our concentration for hydrogen ion? 1 times 10 to the minus 4. Go ahead and do the math. When you do the math, what do you get for a final answer? What is our hydroxide ion concentration going to be? 1 times 10 to the negative 10. And what's our unit? molar. All right, molar. Questions? I want you guys to try example number 2. Right, first step here, guys, you got to figure out if it's an acid or a base, because that's going to give us or guide us to one of the concentrations. What do I have here?
Base.
How do I know I have a base? OH, bless you, because of the hydroxide, okay? So that means I'm going to be able to identify my hydroxide ion concentration first in this problem. What is my concentration going to be for that ion?
2 times 10 to the 0.02.
I have not heard the right answer yet.
4 times 10 to the negative
4 times 10 to the minus 2, which is the same as 0.04. John, why is it 0.04 and not 0.02? Right, guys, there's 2 hydroxide ions here. That's why I wanted you guys to try this and see. Hey, if you had 0.02, you messed that one up, guys, but if you did everything else based on your calculation on that, you're only going to lose some points for not having the correct hydroxide ion concentration. But if you showed me all your work, you're going to get partial credit saying, hey, I knew the process, I just missed one little piece of it. So this 2 right here, we've got to multiply it by the 2 that's there. So that's how we get our 0.04 molar. All right, there we go. 50% of the problem is now done. That fast. Right away, you're going to be able to figure out one of those ions. Now, for the hydrogen ion, it's going to be a little bit more challenging. This is where we have to use our KW expression. H plus concentration times OH minus concentration equals 1 times 10 to the minus 14. Does that number ever change? No, it's a constant, guys. It's the ionization constant of water. It is what it is. It stays that number all the time. Do I have to memorize this number? No, why not? It's in your reference packet, guys. You have this formula in your reference packet. So how do I get H plus by itself? Divide by OH minus from both sides. All right, so my concentration for hydrogen ions is going to equal 1 times 10 to the minus 14 all over 0.04. Now, you don't have to write it in scientific notation, guys, here in this problem. All right, when it's smaller numbers like that, when it's 1 or 2 or 3 decimal places, typically you're probably not going to see it written in scientific notation. You can if you want to. They mean the same thing. When I plug this in, what do I get for my final answer for hydrogen ion? 2.5 times 10 to the minus 13 molar, right? You got to have that concentration unit there as well. Questions? I want you guys to try this last problem here. Again, first step with the problem is to do what? Figure out, guys, if it's an acid or a base, because that's going to tell you which ion you have already given to you. So do I have an acid or a base? Acid, which is going to guide me to what ion? H, right? So I have an acid because it starts with an H. All right, so we have my H plus concentration. What is that concentration going to be? Why is it 2 times 10 to the minus 3? We've got 2 ions here, so we're going to multiply by that. 2 times 10 to the minus 3 molar. H plus is done, guys. Remember, these 2 equal each other. So if you're asked for H3O plus or H plus, they mean the same thing. They equal one another. All right, so now we have that. Let's look for a hydroxide. We're going to use our KW expression. H concentration times the OH concentration equals 1 times 10 to the minus 14. All right, we're solving for OH this time. All right, so our OH concentration is going to equal 1 times 10 to the minus 14 all over. Again, we multiplied it by 2. If you had it wrong, if you forgot to multiply by 2 because there were 2 ions of hydrogen, it's okay. As long as you show your work, you can still get partial credit. 2 times 10 to the minus 3. When you do the math, what do you get for a final answer? Five times 10 to the minus 12 molar. Questions about that? Equation number 2. Equation number 2. pH equals the negative log of the hydrogen ion concentration. And we saw this equation, guys, yesterday in the video. So this is not brand new to us, those of us who were here yesterday. So example number 1 is log of 10 to the minus 7 equals 7. Log of 10 to the minus 3 equals negative 3. So, folks, this actually is not 100% correct. Right, it's supposed to be negative. If you take the log of something, with logs, guys, if you take just the log when it's base 10, so for those of you who have gotten into logs in math class, all right, we're not dealing with anything that's really crazy. We're going to use the log button on our calculator, and that's it. Okay, you don't have to worry about finding if it's a log base 2 or whatever else. These are all log base 10s. All right, if you're not sure what I mean, don't worry about it. For this class, you don't need to worry about exactly what logs are. All right, you just need to know where the button is on your calculator. So when you take the log of something that has a positive exponent, it's going to be a positive number. If you take the log of something with a negative exponent, it'll be negative. But notice, guys, our pH formula, is the negative log of whatever it is. Because our concentrations are always going to have a negative exponent, we have to have that negative in front of the equation so that we always make it a positive number. Your pH will always be a positive number. Jot that down just as a quick reminder. All right? That you're not going to have a pH, folks, that is a negative number. Okay? If you see a number of a concentration, of a hydrogen ion concentration, that is 1 times 10 to some power, guys, you started noticing this yesterday in the video. If it was times 10 to the minus 5, what was our pH? 5. If it was 1 times 10 to the minus 12, what was our pH? 12. All right? Our pH is going to be 12. So if you see something that has a perfect 1 out in front, or if it's just an exponent, guys, like 10 to the minus 5, all right, they equal each other. That's easy. You don't have to plug it in your calculator. If it's any other number than 1 in front of the times 10, you have to use the calculator. You can't just do it in your head. It's going to be something other than just the exponent as a positive. Okay? But if it's a 1 out in front, it's going to be whatever the exponent is except positive. That's just kind of a quick shortcut. Again, if you forget that, use your calculator. You have them. You don't have to memorize it. All right? Here we go. Let's take a look at an example. It says, what is the pH? pH is what we're looking for. Of a 0.001 molar NaOH solution. What is our first step in every problem? Is it an acid or a base? What do I have here? I've got a base because I have hydroxide. Now, my pH formula says what? pH equals what? Negative log of the H plus. Is this substance here going to give me H plus? No, it's not. So what do I have to do first, folks? I've got to figure out what my H plus concentration is, and how do I do that? What's it going to be?
Use the constant.
KW, right? My KW formula, guys, is 1 times 10 to the minus 14, and it would be over the hydroxide ion concentration, right? We've done this. We just did 3 examples, so we all know where I'm getting this, or should know where I'm getting this from, right? Did I lose anybody? I just moved my unknown, got my unknown by itself. Okay, so since, again, I'll just reiterate that, since we have a base to start, we have to go through this extra step right now. Okay, right now we have to go through this extra step and convert it to the hydrogen ion. If we had an acid, we could just take our concentration and plug it right in. It'd make it a lot simpler. So here we go. 1 times 10 to the minus 14 over our concentration. Do I have to do anything to this number? For my hydroxide ion concentration, do I have to do anything to it? Why not? Because there's only 1 hydroxide. There's not a 2 subscript or anything like that. So it's just 0.001. Do that math really quickly. 1 times 10 to the minus 11? Okay. So, by doing this equation up here, we get 1 times 10 to the minus 11. Now we're good to go, guys. We have our hydrogen ion concentration. Now it's just plug and chug. pH equals the negative log of 1 times 10 to the minus 11. Go ahead and do that. Well, hey, we got a perfect base 1 out in front. What's my pH going to be? 11. pH equals 11. Is that acidic or basic? Basic. Does that make sense with what solution we had? Absolutely, guys. We knew we started with a base, so our pH should have a pH that represents a base, which is greater than what? 7. All bases are greater than 7. Identify if it's an acid or base. What do I have?
Acid.
Acid, right? So I'm looking for pH. That means I'm not going to have to go through that step of converting to the hydrogen ion. I already have it. All right, so pH equals negative log of that hydrogen ion concentration. Now, there is one step that I have to do, because what is step 2 always? So after I identify it's an acid or base, what's my second step? Now, writing what's given is kind of a given, right? It's not a step here. Multiply by the number of ions that you have. How many ions do I have here? 2. So I've got to multiply this number out in front by 2. So when I take 3.4 and I multiply by 2, what do I really have? Right. So guys, my hydrogen ion concentration in this problem is actually 6.8 times 10 to the minus 3. So then I can just plug that right in. 6.8 times 10 to the minus 3. When I plug that into my calculator, because this one I can't do in my head because I don't have a 1 out in front of the times 10, what do I get for my pH? 2.2. Now, does that make sense with what type of acid I have?
Yes.
Absolutely, guys. And take it one step further. In the last problem, NaOH, that's a group 1 hydroxide. That's a strong base. Okay? So my high pH of 11 should make sense. I've got a strong base. That's a pretty high pH. Over here, H2SO4, is that a strong or weak acid? Strong. It's one of them you had to have memorized. Okay? That's a low pH. That's a strong pH for a strong acid. My answer should make sense. You've kind of got a built-in check if you know your strong and weak acids. Questions with this problem? All right, so this one, folks, was from the video yesterday. We're finding the pH, guys. I've got a base. We got to get it to be the acid. So again, H plus concentration equals 1 times 10 to the minus 14 over the hydroxide ion concentration. What is my hydroxide ion concentration going to be for this problem? Yeah, 2, right? Because we've got 2 hydroxides. So it's going to be 2 times 10 to the minus 4. When you plug that in, what do we get for our hydrogen ion concentration? 5 times 10 to the minus 11 is what you should have. Now we can go ahead and solve for pH, which equals the negative log of the hydrogen ion concentration. So pH is going to equal the negative log of 5 times 10 to the minus 11. So pH equals 10.3, which is what I told you guys yesterday. All right. Some of you guys got that yesterday, which is great. Some of you didn't, and we're kind of close. But this is the explanation as to how that is the answer. So hopefully it makes a lot more sense today. Questions? Last thing we're going to talk about today, guys, is equation number 3. So we've done half of the equations once we get through this today. We will learn the other 3 tomorrow, and then we'll do a lot of mixed practice for our quiz on Friday. We are going to do the lab on Thursday. Okay? If the plan changes, I will send out a reminder to say, hey, we're going to do it tomorrow and not Thursday. So just be aware of that. Here we go. Equation number 3 looks a little bit different, but kind of the same. So we're going to see, guys, that some of these formulas are related. They're all related to each other, really. Now, what we're solving for, guys, instead of solving for pH, we are now given the pH, and we've got to figure out the hydrogen ion concentration. So our pH formula, guys, we said before, was pH equals the negative log of the H plus. So now, with these problems, we're solving for this. We're solving for that we're solving for that concentration. So really what we're doing here, guys, is just an anti-log. Okay, and again, some of you guys have gotten there in math class, some of you have not. Don't worry about it. I'm telling you what it is. You don't have to memorize any of these formulas. This is in your reference packet. If you're trying to go from pH to the hydrogen ion concentration, this is all you're going to do. So let's take a look at an example. We're looking for the hydrogen ion concentration. Okay? We're given a pH of 7.52. So we're just going to plug and chug in this formula. Hydrogen ion concentration equals 10 raised to the negative pH. This is the equation, folks, where you will use the caret key. When we're dealing with concentrations and we're doing our logs, we use the EE button because it's 1 times 10 to whatever power. Here, we're going to type in 10 caret key negative whatever the pH is. So our H plus concentration here is going to equal 10 raised to the negative 7.52. All right? 3 times 10 to the minus 8. So we're doing the opposite of what we were doing before, guys, with this problem. Go ahead and solve this. Example number 2. Notice what ion are we going to, though? All right, just point it out. There you go. We got pH, so we're starting with pH. We're trying to get to an ion concentration, guys. So we've got to use our hydrogen ion concentration formula to kind of get away from pH. So again, there's our formula for that. So we have a couple steps here. We got to first get back to the hydrogen ion first to kind of get back to the ion concentration. Then we can go ahead and solve for the hydroxide ion, which is what we're looking for in this problem. So here we go. We're just going to plug and chug to get to our hydrogen ion. 10 raised to the negative 3.2. What does that equal? 0.0006309557. All right, so it's a long decimal when you do the calculator. If we convert it to scientific notation, what is it? 6.3 times 10 to the minus 4. Okay? And again, that's going to be molarity. So, does this answer the question? No, because what ion do we have here? What concentration do we have? H plus. We're trying to get to OH minus, guys. So we're going to have to go back and use KW. So we're going to say OH concentration equals what over what? KW, the ionization constant of water, 1 times 10 to the minus 14, all over our hydrogen ion concentration of 6.3 times 10 to the minus 4. And when you do that, what should you get for an answer? Oh, that's a long decimal there, Mikey. We're going to round it. 1.6 times 10 to the minus what? And then what's our unit? 1.6 times 10 to the minus 11. Questions?